wondered how speech recognition will transform learning? Dr. Martin Farrows, CEO of Softbox in Ireland, will talk about this exactly. He is an experienced professional with over 25 years international success in the edtech industry, learning technologies, education, and public policy development. Hi, Martin, and welcome.
Good morning. How are you doing?
Very well. Excited to hear from you. The stage is yours.
Thank you so much, and thank you for the opportunity to speak. Good morning, everybody, from a very sunny Dublin in Ireland this morning. So I am just going to share my screen. Okay, thank you. So just to introduce myself very briefly, so I am Martin Farrows. I am the CEO of Softbox Labs. We're headquartered here in Dublin, in Ireland. And for those of you who heard the earlier presentations, we are actually very proud to be part of that Irish heritage in EdTech going back 30 plus years. And we're also very proud to partner with organizations like Enterprise Ireland and IDA Ireland, who are incredibly effective at promoting the amazing people and talent that we have and companies that we have here in Ireland. But not only are they effective, they're also really lovely people to deal with. So if you ever need to deal with Enterprise Ireland or IDA Ireland, I would highly recommend you do so. So a little bit about Softbox Labs to begin with. We've been in operation for around 8 years now. We're based here in Dublin, in Ireland, as I said, but we have people all over the world. And most of our customers, in fact, would be in the US and in East Asian markets. So we're very familiar with operating in the market where a lot of you are located this morning. It's an interesting question around how speech technology and speech recognition technologies can transform learning for children. Pre-COVID, something like around 620 million children worldwide are struggling to achieve basic reading proficiency. So that's pre-COVID. And then if we look at even just in the US market alone, around a third of US second graders were returning to school in September 2020. So after the initial kind of impact of COVID and the first lockdowns, there were 2 or more grade levels behind in reading. So we know that literacy, reading levels, learning around literacy and language can be an issue. And what we are trying to do at Softbox is to use technology to help to mitigate against some of those challenges. We're not trying to replace teachers. We're not trying to take away from the amazing work that professional educators do. But what we are doing is to say that we believe there is a role for technology in not only improving the way that education can take place around literacy and language learning, but also can add value and bring new potential methodologies for pedagogy and for assessment into that process to help support the role of professional educators. And in particular, this is an equity issue, so where you have, in particular, underserved communities which may not have access to, for example, native speakers of a language, that technology can play a role in helping to act as that kind of helpful adult supporting a child on their literacy journey. So this morning, I want to talk a little bit about Softbox, a little bit about what we do and how that fits into this overall debate around AI and learning. AI is a very broad term. We don't tend to describe ourselves as an AI company. We're very much a deep tech company. We use a lot of AI techniques like machine learning in order to be able to develop our products. But AI as a concept is so broad sometimes that it's not always helpful to use it to describe very specific areas of product development. So we are the benchmark for speech recognition for kids. We've been doing this for 8 years now. We've built a proprietary speech recognition system. Most people would be familiar with speech recognition now in mainstream kind of consumer lives because of the smart assistants that we have in our homes or on our phones. Siri came to the market in 2010, so it's been around for just over 10 years now. And then obviously we have other products from Amazon and Google. But again, these are smart assistants, and smart assistants in themselves are just a very narrow use case for speech recognition technology and aren't all that relevant to kids in the sense that they are actually quite narrow. The use cases for kids around speech recognition are very diverse, they're very creative, and they're very different to the kind of use cases that we need to look at for than we would look at for adults. 2 to 12-year-olds are our laser focus. We used to say 4 to 12-year-olds, but we now have customers using our products for 2-year-old children, actually in Taiwan and in China, where we have 2-year-old kids and above learning English using our technology embedded into our customers' products. In our team, we have over 35 people now, over 130 years of accumulated expertise in speech recognition, in particular around kids. And we have over 50 commercial licenses, customer licenses globally, and that's growing very rapidly. And we've won a number of prestigious international awards. So we are the global leader in speech recognition for kids now, but with a laser focus only on kids ourselves. A couple of really important points to make at the very outset of this that really drive our business, and these are two kind of like core pillars of how we go about things, and they're around privacy and accuracy. So in terms of accuracy, we focus very much on building systems that are more accurate than anything else out there in the market, and we do that for a very specific reason. If you can create accuracy, if you can build a system with accuracy, you will also have integrity in your technology. You build trust, in particular in an educational context. But probably most importantly, the accuracy leads to a better experience for children. So we're all about ensuring that children get the experience that they deserve, that's built for them from the ground up and with them in mind. And accuracy is kind of core to that. The second really important principle for us is around privacy. So data privacy, regulations, in particular in the US and in Europe, but increasingly around the world, very much focus on the fundamental digital privacy rights of children. So you can provide really effective speech recognition technology for kids without compromising their data privacy. In our consumer lives, we kind of enter into this pact with large technology providers where we agree to give up some of our personal data and compromise on our data privacy in order to take advantage of services that they might provide for free. It's not the same with kids. You cannot broach the fundamental digital privacy rights of kids, and for us, ensuring that we are compliant with all of these really valuable pieces of legislation and regulation globally is kind of central to what we do. We're trusted by a lot of partners. You'll see some very well-known brand names there. You'll see some others that are probably less known, but hopefully in a couple of years will be very well-known, like Lingumi, who are a large operator of English language learning products in East Asia. You may have come across. So why is it that adult speech recognition doesn't work for kids? Well, here we have 4 reasons. The first one is that kids' voices are physically different to adults. Okay, so they have shorter, thinner vocal tracts, smaller vocal folds. So physiologically, their voices are different. Their speech patterns are very different, right? So they pause, they whisper, they shout. They're unpredictable. That's the great thing about kids. We can often not predict the kind of behaviors that they're going to demonstrate. They're also not a homogenous group, right? So a 4-year-old is not the same as an 8-year-old. So you have to take into account the fact that when you're dealing with kids, you can't just create a general model that is going to be applicable across all ages within that 2 to 12 age group, because there's massive variations in terms of language and behavior within that group. They also inhabit noisy places, right? So they inhabit kitchens, classrooms, cars. When they're speaking, you need to build systems that are actually designed to work in real world environments. Kids do not operate in a world with headsets and mics. And you can't build systems that depend on headsets and mics to work for kids. So that's a third reason. And then the final reason, and we've already covered this a little bit, is the privacy needs. So they do have fundamental digital rights. Things like, the right not to be micro profiled for advertising and so on. So you have to be fundamentally taking an approach of privacy by design when you're working with these kind of technologies and children. So that's all the reasons why adult speech recognition does not work for kids, and why there is a need to build something from the ground up for children. I did have a video here that we were going to play, which demonstrates how voices change with age. The video is not going to work through this third-party platform. It's a bit too laggy, but we can put a link to the video after the presentation. But what it shows here, you can see actually on the still on the screen, is 5 different kind of speech patterns. So at the top you've got an adult male, and at the bottom you've got a child age 4. And they're saying basically, these are all saying the word umbrella. So you can see the massive difference in that speech pattern from the top graphic right down to the bottom graphic, and how it changes from an adult male to an adult female to a child age 10, a child age 7, and child age 4. And what we're asking a computer to do is to be able to understand that both the top graphic there, an adult saying umbrella, the bottom graphic there, a child saying umbrella, they're both saying the same word. How is the computer supposed to deal with this massive difference in terms of the speech patterns and understand that both of those individuals have said the same word? So that's just really scratching the surface in terms of why it is so difficult for us to build speech recognition systems for kids specifically. That's ignoring things like dialects, like accents, like the fact that a child might, say umbrella instead of umbrella just as a word. The child is not going to adapt their behaviors in order to be able to mitigate against some of the shortcomings of technology. So we have to make sure the technology itself is able to take into account the differences that children might have. Let me just click on there. So in terms of the engine that we have built, and we refer to this as an engine because it's a useful kind of metaphor to use to describe how we deliver our technology in order to support lots of different use cases. We operate in 2 main markets. The first one is play, so that's kind of consumer market. So this is kind of toys and robots and anything where a child might be looking to interact with technology using their voice in the home. And then on the right hand side, we have the kind of educate sector, which is the one we're focused on today. So I'm just going to kind of focus in on that one predominantly during this morning or this afternoon for you guys. So in educate, we can use speech recognition technology to fulfill a whole range of exciting use cases. So the obvious one would be at the bottom right here, pronunciation assessment. So we can assess down to the phoneme level how well a child has pronounced a specific word or phrase. And then we move into kind of other areas of assessment or measurement of reading practice. So things like fluency assessment, how fluently are they reading? We can do things like keyword spotting and comprehension questions. So you can ask a question like, what is your favorite color? The child comes up with their favorite color, and we can pick out that word within a sentence and then start, for example, a dialogue with the child with an avatar or a character on screen. We can do multiple choice questions. So the basic message here is that this engine that we have built is actually incredibly flexible and agile and adaptable to be used for multiple use cases embedded within a product that you would be using for either literacy or language learning purposes. What that means is that we can support that kind of literacy and language learning journey right through the process. So right from the early stages of language development and what we call phonemic and phonological awareness, right up to where we're teaching from a literacy perspective around phonics and letter sounds. We can identify individual isolated letter sounds. Then you move into kind of words and sentences, and you're then moving into the area of where the child is reading to learn as opposed to learning to read. You can start looking at things like fluency and comprehension. And speech recognition technology can be used throughout this learning journey. But the key part about this is also the consistency that you get by using the technology throughout that learning journey. And this comes back to the issue of comparing how a speech recognition technology might compare to a human assessor, for example. Throughout a child's learning journey, they're unlikely to have the same human assessor assessing them from the age of 4 right through to 10 or 12, for example. But if you're using technology and using a consistent platform through that, you can actually build up a longitudinal view of how the child is developing through that learning journey. And you have the kind of integrity and consistency of the platform, and removing elements of bias and just human error that might come into the process. So it can actually play a really significant role in terms of improving consistency in that regard. These are the kind of areas that we work in. So it can be everything from like formal or informal assessment. So where you have periodically throughout the year an assessment where you're testing, well, how well is the language acquisition going for that in particular child. For intervention products, we do support for screening for things like dyslexia, for example. You can use speech recognition to provide support for kind of rapid naming activities, for example, reading practice and instruction. So any type of product area that you might use in the education space, we can support through speech recognition technology. I want to bring this back to the kind of AI part of the conversation and the unique value of voice data. Most AI solutions, most machine learning based applications within education really come to life with the large volumes of data that we now have and can start to interpret and build models on. And this is no different with voice, right? So in many ways, voice data is a new category of data when we think about education. Typically in education, when we're thinking about literacy and language learning, the assessment takes place with a human listening to the child and then annotating or noting down how well the child is doing. What we can do with voice recognition and the speech recognition software is actually compress that process and make it much more scalable, right? So you can have a child practicing their reading every day. The computer is listening to how they're performing. It's aggregating data about the child and then feeding that back to either a parent or a teacher or to the child themselves in real time. So the value of this voice data ecosystem is really important. So for kids, you've got real-time feedback loops. For teachers, you can generate dashboards with actionable insights, which saves them time in terms of productivity, so they can just focus on areas where they need to intervene with the kids. For companies that are integrating this product, they get valuable insights in terms of the actual product that they're building, in terms of product improvements and so on. How well is it being used? What areas are being used particularly efficiently? And that, again, that data is delivered in real time. And then for schools and school districts or authorities, government bodies that are actually delivering education as a public utility, they can also take those kind of reading records and ingest them and see how, for example, different schools or school districts are performing over time. So the value of that voice data over time is incredibly important. And that, I think, is one of the key areas that we take away from the use of this kind of AI technology in education, is that we can gain insights that we wouldn't necessarily be able to gain as effectively, either immediately or longitudinally over time. Again, we have some use case videos here. They're not going to work live in this presentation, but you can see here we have a phonemic breakdown example, an early literacy example, and reading fluency example. Again, we can put links to these videos. They're on our YouTube channel, and people can look at them afterwards.
So
you can read about us. We get a lot of coverage globally around the work that we're doing because we're such a mission-driven organization. This is a quote from Marjorie Mayer, who's a very experienced and well-known practitioner and former president of Scholastic Education in the US, who tried to use speech technology back in the kind of late 90s, early 2000s. The technology wasn't working well at that time, but now feels that the time has come that we can actually start using this technology to tackle not just the global literacy challenge, but also in a practical way by integrating in current and planned literacy products. We have a webinar next week on September the 21st ourselves, looking at how you can voice enable math and literacy tools. You can find out about that, and anybody who wants to download our current white paper or read the TechCrunch article that came out last week around the power of speech recognition can do so. So thank you very much for listening to me this morning. I look forward to participating in the panel discussion.
Wonderful. Thank you so much, Martin. We will now switch over to the next session of AIBotics Go Digital series.